we are having some awesome panelists who would be speaking and would be delivering what they have been able to achieve so far in irrigation, and how the new models from IoTs to machine learning and artificial intelligence, it is impacting the irrigation part as well. To start with some, I'll give you a few pointers. 70%. I'll just give example of rice. Rice is not an aquatic crop actually, but for decades it has been growing actually in a very water intensive manner, where we have been doing in 90% of the cases flood irrigation. So unfortunately, it's just not about wasting of water. It also ensures that more methane is produced by using that practice. Now, there are some small experiments happening across the globe. For example, GIZ and where they have done an experiment in Thailand, where close to 100,000 farmers, they are actually using drip irrigation in rice also. And it has actually given pretty decent results. And the yield was as good as when it was being done for using flood irrigation. New modern technologies need to ensure that actually the water guzzling crops like sugarcane, rice, we adopt better practices to ensure that we reduce the use of water. Otherwise, already in India, 18 cities actually are having water deficiency. Some of you would have lived in Chennai, they know actually what impact it can have. Where actually you have to decide whether today I need to wash my clothes or take a bath, right? So those type of challenges actually the human society would be facing unless we become smart enough to utilize the resources the Mother Earth has given us in a more sustainable manner. And again, as I said, agriculture needs to change substantially. The way we are growing crops, it needs to change substantially. Yesterday we had a session on climate change, right? The patterns are changing. So those places which were not actually conducive to grow a specific crop now are becoming conducive. At the same time, the places which were conducive to grow a specific crop, now no more it is conducive, right? So we have to identify the right crop for the right areas. And so to start with, I would be inviting Jasveer, who is the founder of Sense It Out, and they are doing awesome work in using sensors to ensure that they are able to identify what is the moisture level of the soil, and based on that, the algorithm is able to do the irrigation in a more optimized manner. Jasveer's team claimed that actually they have been able to reduce the use of water to the level of 30% in some of the crops, specifically in horticulture. So I would request Jasveer to take over and deliver insight of what they have been able to achieve and how they want to take it forward. So yeah, Jasveer, please.
Thank you, Deepak. I think you rightly pointed out some of the issues which I'll be talking about. So I'll be talking. I'm Jasveer Singh. I'm the founder of Sense It Out. We are based out of Pune, and today I'm going to talk about smart irrigation. And I'll start with irrigation, and eventually I will move on to smart practices and what are the problems and how these smart practices can bring solution to, and then also give a small case study of how we are trying to tackle it. Okay, so what irrigation is, the dictionary meaning is that the artificial application of water to land to assist in the production of crops. But the way in which FAO sees irrigation is not just for crops, it also takes into consideration the livestock. So he just rightly pointed out that 70% of usage in agriculture of the fresh water resources are being used out in agriculture, not just in crop agriculture but also livestock. So it includes 45% in crop agriculture and 25% in livestock. But this is a global average. What is the Indian scenario? Indian scenario is that 90% is being used in agriculture, 65% of which is in crop agriculture and 25% in livestock. So when 65% is being used, I mean there is definitely something wrong that we are doing, and I'll eventually come out with how less water we will be able to do much. And there is this big question that if we want to really achieve by 2050, we say that we want to double the food production, but the water resources are going to be same. There is no new river that is going to be created. There is no additional. In fact, it is depleting. So how is it possible? And there are few more apart from this question, there are a few more problems. The existing farm practices that is leading to reduced yields. It's actually the problem why the yields have been reducing is because how a farmer today practices farming is that I will flood the farm today and then I will again water, again flood after 5 days or 7 days or sometimes 15 days. So we are giving at the micro level both drought as well as a flood type of condition which is affecting the yield a lot. Then we are also, whatever water holding capacity is there, only that much water is going to stay in the soil, rest all is wasted. Okay, and how does the farmer actually make decisions of irrigation? So he sees that okay, water is being subsiding in, and now water is starting to stagnate. So वैसे तो 5-7 inch they stop, but suppose if he stops at 1 inch of water table above the soil surface, 1 inch of water table on an acre of land is about 1 lakh liter extra that has gone in. Now 1 lakh liter per acre. So many acres, we have millions of acres, 68 million hectares that we have in India, okay, and that much amount of lakhs of liters of water every day. So, basically it's a knowledge problem that we are struggling with. Now, what are the limitations of the available solutions? Available solution, you can say that we can easily solve this by drip irrigation and timer-based automation systems. But these drip irrigation and timer-based automation, again, we are not solving the knowledge problem. Okay, here the decision making is still by the farmer. The farmer is intervening and deciding how much amount of water. So 3 to 4 hours every day, if you are still going to use with drip, it is still a waste. And water wastage is not going to reduce. So the solution is going to be sensor-based irrigation. But let me tell you, it has sensor-based irrigation has its own challenges. To give you a background, let me show you this image where you have two comparisons. One is both are satellite images taken at same scale of 100 meters. On your left, you have Colorado, USA's potato farm. That huge whole circle is actually a farm. Okay, and then on the right you have a farm in Maharashtra, India. Okay, can you see the difference in the sizes of the farm? Each farmer is having, in India, the average land size is only 1 hectare. Okay, so what happens with that? We are not able to mechanize a lot of things. Like there, definitely drip irrigation can be done in farms like US big farms, but then better sense is center pivot irrigation which is done, which you cannot take to India. There, the mentality of farmers is different. It's more business oriented. They would sell at a large scale. So farmers are smart there. They are business oriented. In India, the farmers are having knowledge problem. Farmers are also smart here in India in their own way, but then they have a knowledge problem to accept. So in India, we would need to give a automation type of system. Just by giving, like in US, if you give sensor-based advisories, okay, today this much water, tomorrow this much water, they would actually implement it. But in India, they would intervene and actually, no, water, it needs to be watered more by the existing practices. So an automation system is required. Let me talk about the challenges of the sensor-based systems and give you an Indian perspective. In India, ROI is a very big factor. If the returns, if we are investing so much in a sensor-based system that we are not able to get returns from, then it doesn't make sense. So in India, these solutions which are available outside sensor-based systems, these are expensive, they are reliable, but when we bring it to India, they are unaffordable. And affordable solutions which are now being built for Indian conditions are really not reliable, so still cannot be used. And then there is irregular electricity problem. Farms are available with 2 hours, 4 hours, 6 hours or 8 hours of electricity every day. Now sensor says water requirement is going to be there to the controller which is placed close to the pump, but controller is saying, no boss, electricity is not there, I can't turn on the pump. So the whole system goes for a toss. So what's the solution? We can talk about problems all day long, but what are the solutions? So first, let me tell you what is the ideal scenario and what are the components that we need to bring into picture for the solution. First thing, the sensors which were costly, we need to make them affordable and reliable. But ऐसा ही होता, affordable और reliable कर सकते तो क्यों करते हैं? So we really, the expense comes at the cost of accuracy. So we need not be accurate, but we need to meet the requirement. And if we are able to do that, just talk about dry soil and wet soil, the field capacity to the wilting point. It's a good start. Then the irrigation needs to be optimized at the root zone. So different crops have different root zones. So we need to build different crop models where we need to take into consideration the water stress requirement, the root zone levels. Different types of crops have different root zones, and the root zone also varies depending on the crop and the crop stage. So we need to take into consideration that, and then we need to manage drought. So a lot of times the farmers know that if I irrigate more today, in January suppose, I'm not going to have enough water in May or June, but still they would keep on irrigating. So we need to do that management. We need to irrigate maybe a little less now so that we are able to survive in May or June. We also need to cater this electricity problem. We need to take into consideration the electricity schedule which is being provided to the farmers, that these many hours are. So this week, Monday, Tuesday, Wednesday, morning 6 to afternoon 2. The other days, evening 4 to night 10. Whatever considerations, these need to be brought in. And then we need to also, the sensors, we can be smart only when we are able to bring in the next irrigation cycle prediction. And if we are able to do that, and that can only be done with the help of, if we can do find out the rate of soil evapotranspiration. So we would need rate of soil evapotranspiration sensor. Then another problem is there is no trust in technology with farmers, and we will need to bring that back. And why that trust is not there? Because we want to change the behavior. So farmer, if my technology says in the root zone water is enough, but on the surface, if he doesn't see moist surface, he would irrigate. He would say that no, your system is not working. So we would need to bring trust into the system. How? By use of infographics, make farmer aware of his farm status. We have these app kind of technology. Every farmer is now having an Android app, most farmers at least. We can tell them about what is the soil moisture levels below the soil surface at desired root zones. We can communicate with them whatever the urgencies are there, and use the notification judiciously. Today they are getting notifications for almost everything, but we need to judiciously use it so that he keeps a trust. Okay, now the notification, this must be important, then only this notification has come. We also need to introduce remote diagnostics. These sensor-based systems will always have problems. The sensor might fail, whatever. But we need to, as a company, as a service provider, we need to remotely diagnose things and understand today's sensor is failing. Today, maybe the water has run out, maybe the pump is in dryer, and that is why the water is not reaching the farm. We need to understand all these things sitting at remotely, and again communicate back to the farmer that this might be the problem. Maybe the water has run out of your reservoir. Maybe you need to check that and stop the pump. So, combining all this, I'm coming to our system, which is SICA. SICA is sensor-based intelligent crop-centric automation. It's a smart irrigation system that we have built as a company, SenseIt. And this is a small video of how it works. So a sensor module is placed at the farm where soil moisture is measured at various levels, and if it sends dry at the root zone level, then it will wirelessly send a signal to the controller, which will then take a decision of how much to irrigate, and optimally it then irrigates and gets a feedback that okay, is optimal amount of irrigation is reached. If it is reached, then a signal again that the pump has to be turned on. This is an Indian scenario where we need to bring in automation. Okay, but we also need to be scalable. There are a lot of farms in India which so which are large. Okay, so we have developed a system which is scalable, and we can scale it to up to 1,000 acres. We are using LoRa based communication, so wirelessly we can go up to thousands of acres. So this system can be implemented in India as well as in places where there are large farms like US. And then what will be the benefit is that what we have seen, in fact, with our trials, that we are able to save about 80% of yield. There is a potential of yield increase up to 2 times. We can save a lot of energy, but we still need to address the electricity problem. So we have developed a rate of soil evapotranspiration sensor, which will predict the next irrigation cycle. How it will actually measure the rate of leaching, the rate of evaporation, the rate of absorption, and with that we would be able to give the next irrigation cycle prediction. And with that, suppose the next irrigation cycle is now predicted at 36 hours. Now the irrigation was done, and now it is predicted because of evapotranspiration. The next irrigation requirement will be after 36 hours. So when the electricity comes at the 24-hour interval, then we'll make again a decision that okay, now another time electricity will come after the 48th hour. So now let us irrigate to the field capacity, so that the next irrigation cycle is again pushed beyond the next electricity availability. This way we will be able to counter that problem as well in the Indian scenario. We are incubated at Venture Center in Pune. Got some grants. Also incubated at Pusa Krishi Incubator in Delhi, and we were one of the Smart 50 startups to transform India, recognized in 2018 by DST and IIM Calcutta. And we have been in the media. So that's it. Thank you. And if you have any questions, I'm open for you. Thank you.
I represent Trimble's geospatial business vertical. So I'm presenting on behalf of Subhash Patnaik, who's actually heading the agriculture business. There are a few areas that before I start my presentation, I would like to let you know, and probably it will make sense in India's context. As we all know that the population across the world is growing heavily, and we'll reach a stage wherein there will be a lot of people who will be hungry. But at the same time, since the growth will happen at all the levels, the number of people who will be demanding the quality of food and the requirements around the food will increase. That will make life very difficult for the farming community and also for the governments. There are various areas through which you can increase the crop percentage in a year, but we'll need something else to ensure that we improve our processes systems, so that we can cater to this kind of a requirement, which is like India's context. And we know that by 2020, around 9 people would need 1 hectare of land to feed. So that's a huge number as compared to 1960, wherein we had less than 1 number of people depending upon the land available to us. And this number can change very rapidly depending upon the requirements of the urban cities getting developed very fast. And we have seen the example of both Hyderabad and Bangalore and Pune in the last 15 years, how they have grown. Another slide that gives you some idea how this gap can be reduced. Obviously, the land requirement will reduce. The losses will be improved because of the processes adopted by the farming community and the technology providers. Farm practices can also improve the productivity, but we will need technology to cater to the 80% of the requirement from 150% that we need by the end of a particular year. Before I move to that, we are a global leader in providing the GPS technology. Trimble was the first company that made GPS technology available globally to the commercial sector. We are a 40 years old company, and our products are being used across wide spectrum of industries, and we have been growing rapidly, very all across the world in all the sectors. As far as our verticals are concerned, agriculture is one of them. Heavy civil is another area. Building construction is our recent development in terms of the software that we acquired in the last 5-6 years. Geospatial has been a backbone. That's a very large division. And transportation and logistics is another area where we work. Globally, we are close to 11,000 people, but in India, we have a very focused area. We have about 1,100 people sitting all across the country, Chennai being our largest area, where we have about 600 to 700 people sitting in the same office, working on requirements for India and also global requirements. In terms of the lineup, all of you will understand this much better than me, but I think these areas are important when we look at the life cycle of any project related to agriculture. This slide shows where all we need highly mechanized system and low level of mechanization, starting from land development to post harvesting, and that's one of the area where I will talk about on the land management. We know that apart from the land and other scarcity that we are facing, water is another area which is eating up a lot of our resources. And currently we have there are certain very productive cost giving or revenue giving crops that are being grown. That will be very a huge challenge that will pose going forward. So rice, cotton, and sugarcane are very water intensive crops that we know, and we also have information from the geospatial side where we know that the groundwater crises are even more deeper than we always think of. So that this chart gives you that idea. So which means that the farming community will face more challenges in these areas if they continue to grow the way they are doing right now. There is another area that is we have seen wherein the traditional leveling of the field can lead to a very high level of unproductive work by the farming community, and that is one area that we address. So we go from a very basic level of technology to a very high-end technology in our offerings. This gives an example of that. So laser leveler is one area where we can provide our technology. There are three areas out of the 6 pictures that you see here: transmitter, receiver, and the control box. That's the technology in which simple GPS equipments are being placed. Rest are done through our partners who integrate the system. Just to give you an idea how it works, so there is a tripod on which the transmitter can be placed. There is a receiver that can be put on a farm, on a tractor, and then there is a control box that lets you do the basic work that we see in the field. This reduces quite a lot of work for the farming community, and it increases the output. Most importantly, time and water, which is very critical these days. Because of the timing of the crop, we see so much of pollution in Delhi. If they just prepone the way they are growing, we will have less pollution in Delhi. There will be a 20 to 30% of water savings, which is going to be very critical when we move forward. More importantly, from the farming side, there will be improvement of about 8 to 10% of the yield. So these technologies help you there. These very simple technologies to adopt. Second one is the way the nutrients are being put into the crop, and there is a small technology that helps that. And we have seen in India so normally we need a ratio which is 4:2:1 for nitrogen, potassium, and phosphorus and potash, but we are overdoing there as well. So there is a high quantity of nitrogen being put into the crops, and we don't get the yield as it is. A very simple device that helps you cover that. This is a device which lets you pick up the information from the field and use it, and the farmer can find out very simply how it can be utilized in a crop. The readings can help it. Even a farmer who doesn't know much about the technology, he is the consumer of this technology. We have seen many happy farmers in North India. I'm sure they will have much more all across the country. Since all of you work with aerial and UAV data, because large fields require some level of data collection which is very fast and quick, this is an example of buildings. This is a very interesting technology that Trimble has, wherein when you capture the images, mosaicing and making orthorectification in an image can be done very easily by a lot of technologies. But what we can do is much more than that. In this example, if you have images, you can from that, if you define certain features, those features can be picked up by the software. And for a farming community, there is a very good example in our region, which means Asia region. This is an example of land. I am quickly jumping to the irrigation side. In this, we can see if there is a construction going on in a particular area, we can find out the changes there. and you can count the number of houses that have been built in that area. So these are the technologies that we can use. Most important one for the audience today is this one. We can count the number of trees, which is impossible by any standards. This is a live example where in the palm oil industry in Southeast Asia, in Indonesia, they can find out the health of a crop through image analysis, and they can predict how much production of palm oil they will do, even when they are they're in the process of making the crop grow. No technology can do that today. This is the most intelligent tool that is being developed by us. It has got artificial intelligence in it. The people who are actually consuming it, they don't need to do anything. Just play and pick the images here. There is an engine that runs behind it and it gives you the output. In this, you can also define the type of trees being grown there. So if you have a mix and match of trees, you can also find out if there are mango trees. Okay, this is the output that we are expected to do. Or if it is a sugarcane farm, with the length you can find it out. So this technology can also find out the length of a tree or a crop. That can tell you whether the crop will be healthy or not. So that's an interesting area. That this is a part of a geospatial technology, but can be very well used in the irrigation side.
I'm talking about the borewells that are feeding water to crops, which could be the paddy, which could be the sugarcane or groundnut or any of these crops, cotton kind of things. Out of this 14 lakh borewells, the total amount of water pumped is 945 TMC. I come from Karnataka. Most often people from Karnataka and Tamil Nadu always fight on an annual basis. That is for water. When the water dries up in Karnataka Kaveri basin, invariably Tamil Nadu will have a problem. So we fight for roughly around 20 to 30 TMC of water. And that fight has been kept alive for last 30, 40, 50 years. Now here we are talking about 947 of say roughly 1000 TMC in one state. Right? I think basically if we leverage on the technology, we don't need to really worry about fighting. That same amount of effort, the amount of money that they are spending in fighting the legalities of those things can be well utilized to save the water and move forward with the technology. And look at the power consumption, 1257 crore units annually. And the amount of money Andhra Pradesh government is spending is 9000 crores. And what do they do with this 9000 crores? They provide 9 hours of electricity to farmers, which is free of cost. So all we are saying is, if you move away from the flood irrigation to any other alternative, a simple method, that can actually help the farmers to save roughly around 20 to 30% of water. In essence, they don't need to lift so much of water to the ground. So that means directly they will be able to save 20 to 30% of electricity. So now all of you are good in mathematics. 20% of roughly 9,000 crores is 1,800 crores. You can imagine the amount of money that government can save. Right? These are the three benefits. Now what else we do? Basically we have got three offerings. One is we have categorized the crops into two things. One is the water guzzler that are not of commercially rich value, such as paddy or sugarcane kind of thing. So we have got actionable irrigation advisory. So we just send a message to farmer, we follow up with the messaging closely. We keep measuring or monitoring the soil moisture. At the end of the day, we tell the farmer saying that how much water should be there and how much water did he do. Accordingly, we bring in a corrective action. And second set of projects is basically the commercially rich crops such as banana, pomegranate, grapes and all, where there is a commercial gain for the farmer. So obviously, we do the complete irrigation. I will not get into technical because it will be boring for you once again. And the third one is the smart fertigation. While irrigation is a very important aspect of agriculture, fertigation is equally important. Both irrigation and fertigation, if managed well, definitely your productivity can shoot up by roughly around 50 to 60% across crops. Just take 1 minute, okay, to illustrate what is the meaning of precision irrigation. I am sure if not all of you, some of you are here from morning 9:30 and will be here till evening 5:30. How would it feel if the organizers say, we are going to give you water at 5:30 once a day? Is that acceptable to you guys? No. But that's what we are allowing our farmers to do. As part of irrigation, what are they doing? They are watering once in every 10 days, 12 days, 15 days. And as a result, the water stress is going to be too high. When I say field capacity, that means the crop is submerged in water to some extent or the soil is completely covered. That's what we call field capacity. And wilting point, that means the plants are almost about to die. They don't have any more energy to take the water. So that's what it's all about. Now once you move into the next one, which is drip irrigation, is a basic irrigation method where they use the drip irrigation pipes to run the water. That is slightly better than the previous one. But when you talk about the sensor based, right, where the watering can happen based on the available moisture or the crop demand, obviously that's going to be far better because the wilting point and the field capacity are never going to be breached. So it's something like rather than giving water once a day at the end of the day in the beginning, it's kind of giving in 3 or 4 intervals. All of us can enjoy. There is going to be no wastage, no stress to anybody. So this is what we are talking about, a very simple technique called alternate wet and dry, where we flood the field for a period of 3 to 5 days time, and the soil will be soaked with water. Then afterwards we let it dry. The critical point here is we do not allow the soil to completely dry where the plants are going to suffer. We understand technically and agronomically what is the point from where the watering should start. And the other thing is smart irrigation system, where we are also having a sensor-based irrigation, where a soil moisture is measured on a regular basis, hourly once. And depending on the available water, the system is going to manage the entire thing seamlessly, understanding when is the electricity and what is the water requirement, how old is the crop, what was the temperature today, did it rain actually, did it drizzle or did it downpour. All those things will take into consideration and provide right amount of watering without any human intervention. This is a very simple thing, I am sure you have seen in one or the other farm. This is a target segment. As I said, we have got 3 categories of crops. One is the water guzzlers, second one is high value but still water sensitive, third one is water sensitive but B2B focused, like it could be the greenhouses. Most often in foreign countries and all, when they talk about greenhouse, their productivity is close to anywhere between 50 to 100 times higher than what we are doing in India. In India, the definition of greenhouse is instead of growing in the open condition, let me take it to a controlled condition and grow it. Right? So that's why it's making a big difference. So when you have the right technology, the productivity can be far higher, making most of these farmers and their investment into agriculture more viable. This is how we are using the technology. One is understanding basically what are we getting from the remote sensing in terms of NDVI factor and correlating with the ground realities. This is the dashboard we give it to the field officers, not necessarily to farmers, so that they get a sense. Because right now what happens, there is so much of difference or so much of gap between the people who are managing agriculture and people who are actually carrying out agriculture. Our whole idea is not everybody will be understanding in the farming segment about these things, but the moment they start seeing a graph, we will be able to understand and analyze the moisture has gone up or moisture has gone down. Very simple terms. These are some of the recognitions we got. I'd like to conclude saying that we are here to work with the farmers, help them increase their profit by 30%, save water, and reduce wastage of energy. Any questions, you could always reach out to us and cultivate our. Thank you.